So, I've been thinking about this exercise here, and I know it's penciled, but I'm going over the bits and pieces. And here you see the transformer feeding the track, and the only things you need to worry about is most transformers are AC output, and in this case, there's a variable post and a fixed post. And the fixed posts are usually for lights. Oh, let me turn this down. Old Beatles stuff, a little noisy. There's like building lights and signs or something you want to light up. Then you use the fixed post or an accessory that you can trigger by the track, off the track by the train going by. In any case, the 0 to 17 volts AC is where we get our power to run the engines. And even when we have DC controlled trains with the built-in remote, we're usually cranking that to 17 AC to the track, and then we run the speed through the remote controller. Okay, so then I based three systems: the drive components, the smoke components, and then the sound components, and I drove them off of then the supplied track power. So now you know where this comes from, so I don't draw it again. So here we have the track power coming into the Lionel 0103 controller, which takes the AC variable and puts out the DC as a variable, so it's almost one-to-one, some loss. And then that just goes to a DC motor, and that runs the train. That makes the train go forward and reverse, and you have a neutral for pausing. So the drive components, which is, the first thing we do, is the easiest. You can make the train run quickly. Now it gets complicated when we get to the smoke. The smoke itself is just a heater, and all we have to do is give it 9 volts, and it'll smoke. Now, the smoke won't come out unless there's some airflow. In the mechanical action of the old trains, there's a piston going in and out, driven by the crankshaft, and that pushes the air out mechanically. When we go to digital, then we have to have a fan blowing the air out. And that's where it starts to get complex. A couple of reasons. One, the fan needs to be controlled, and we don't want the fan just on. You want it to puff. You want it to puff when there is an exhaust in the steam engine, or timed in some way. Either 1 stroke, 2 stroke, or 4 strokes per revolution of the drive wheel is the typical timing that is used. So in order to get this thing to time right, it has to have some kind of a trigger, and here I drew my cam, which is in synchronization with the drive wheel, so that it turns one rotation to the rotation of the drive wheel. So we have these little cams on it, little bumps, and the little switch is triggered when the wheel comes around, once per lobe and 4 lobes per revolution, so 4 triggers per revolution. Then that trigger goes to the puffer board, which you know very well, and of course that sends a pulse to the motor to say fire. I had tried running 5 volts right from the trigger, but I always had run on. And when you're dead stopped, like when you stop the train and this voltage is coming off of track power, it goes to 0, this fan stops, there's no airflow, and the heater coil builds up, and can prematurely burn out because it gets overheated, because the airflow actually lowers the temperature. You know that. That's when it gets complicated, when we want to try to think about compensating for airflow. That's when we moved into the smart smoke idea, where you have a variable smoke voltage. So now you have the heater coil, but you now have a sensor to tell you the temperature, the thermistor. And you put those into a type of a variable regulator board that we've engineered 1 or 2 by hand, you know what I mean. So you have volts coming in, and you have the thermistor, and it automatically regulates the heat based on the temperature. So you're calculating volts based on heat. This we've built, it did work. I need to get back to that because, as we saw just yesterday, even with this system, if my fan is not reliable or something happens, this is open loop. This just takes off. And I had reading errors on the output, so I was up to almost 11 volts at one point. No wonder it melted. Okay, but we need to have that temperature sensor in there as a safety, as well as regulating to get good smoke, constant heat. 120 C is the range we want. Anything over 140, we're at risk. Okay, so this piece needs to be considered as we go forward. And I'm thinking in the engine, and then of course what space is needed. Okay, so that's the transformer, the drive, the smoke. Then we got down here to the sound system. And what I'm finding in my own brain is it looks like we have two sound systems and maybe even two speakers, where we have the chuff board getting its 9 volts, getting the trigger signals fairly simple, and then it goes to a speaker. I mean, we had that running just the other day, right? So we're happy with it. Not happy with the sound itself, but I think we can tune that, putting some knobs in here or something. But now, then we have the remote, and just this morning I verified that this remote, going through the receiver to a relay to a soundboard to a speaker, will work. It will. So that's kind of, we know that's going to work. Then I start thinking about where are we going to put all this stuff. So I did a very crude and rude cubic inch, how much space do we really have here? This is the shape of the tender. You'll be getting a few of these. And you can see it's long, it's got a notch in it. It does have some ventilation, which is a good thing. But it's about 1 3/4 wide. Oops, there I am. 1 3/4 wide and about 5 1/4 long. Some of the longer engines have longer, 5 1/2 maybe, length. So you have a little more length in bigger engines. And about 1 3/8 to the top. Now this coal is molded in a shape, so it's highest at the top and lowest at the bottom. But I had ideas of just grinding this completely out and filling this even up over the brim with phony coal, or just drilling it out and pushing it up and then filling it in, so that we end up with more cube on this half where the coal is higher. It all depends on what we end up with. So you've got the two rectifiers, which I don't know if we can just use them, like everybody who needs 9 volts taps in here, everybody that needs 5 volts taps in here. I don't know if that's going to work. If you wanted 5 volts to that motor and you want 5 volts to the soundboard, that doesn't sound like a big load to me. But if you're putting 9 volts out to the heater, that 9 volts is going to be taken, So now if we want 9 volts to the receiver, that, again, it doesn't sound like a lot, or even to the relay. I think that's a minimal amount. It's not going to hurt the smoke. But again, if we have the thermistor in there and we see the temperature starts to drop because the voltage is being sucked off, this boy will say, a little more volts here, please. You got it, here it comes. So we can accommodate this. This I see, I keep going back to this as a hot item. So anyway, we know this works. We know this works. My area of concern is this guy. And even Carl's board works on the bench, but when you go to put it in, it's a little iffy sometimes. So it all could be my wiring, it could be my motor installation, my trigger, it's all different. So I'm going to work on this piece to try to get this a little more in the reliable state. We know the Lionel thing works. We do have a chuff board, soundboard, right? Puff board not. Soundboard, yes. And we have the remote sound almost. I need to program or load in the sounds for the soundboard. That's a mini USB, and just download it like you're loading a USB port, that. And then I need to get I didn't put in the amplifier and then the speaker. Okay, so I'm going to put in the amplifier. I'm going to build those on a breadboard I have some boards I bought, so I'm going to be building this as a breadboard circuit. They're pretty small boards, actually, except for the relays. Relays sizable, you know, but that's 4. I wonder if I could get that in a 2. Oh, I did get the big guy in a 2, but what I didn't realize when I got it was the 2 levels are high and low. It's not on and off. It's a high and low, and that's digital. And now I got to convert that to some on off somehow, and I can't. I don't know how. I put it. All right, I'll admit it. So can't use that. Damn it. At any rate, the smaller one's better. It's just that if we run into a space issue and we only want to do 2 sounds, the whistle and the bell, then we could get a smaller board. You know, this relay board could be cut in half. We'll see. See if we need to do that. But if you stack up the boards, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. We haven't even gotten to lights. 9 PC boards. All right, here comes the boss. Cheese it, okay? That's what we have to figure out. What's realistic? How can we stack them? You know, can we really put them in that stack? I'll talk to you after lunch.